Assalamu alaikum. Welcome to my presentation. Today's topic is about mesh and node analysis. I am Alfa Mishmam, ID C221031, International Islamic University, Chittagong. So here we have two questions related with mesh and node analysis. As I said before, that our topic is about mesh and node analysis. We will start with the mesh analysis. So here we will know what is mesh analysis and how to solve the questions about mesh analysis. Mesh analysis is a general procedure for analyzing circuits using mesh currents as the circuit variables. To solve the questions related with mesh analysis, we need to know the following terms. One is Kirchhoff's voltage law and second is Ohm's law. So what is Kirchhoff's voltage law? We can assign Kirchhoff's voltage law as KVL. Here KVL means in a closed loop. In a closed loop, the summation of all the voltage sources are equals to 0. So there are the steps to determine mesh currents. The first one is assigning mesh. We need to assign 1, 2, 3 as the numbers of the meshes. Then we will apply KVL to the meshes separately and then solve the equations. So we can see the questions about the mesh analysis. So in the solve, at first the thing is we will assign the mesh currents. Here are the mesh currents. We can see we have assigned them as I1, I2 and I3. Then the second step is applying KVL all of them. So for applying KVL, we can start from any branches. If we suppose in mesh 1, here the 7 ohm as KVL, as the rule of KVL, 7 ohm plus 31 voltage, we will assign the only the summation of voltages. So for the summation voltages, we return the 7I. Here 7I means V is equal to IR as the Ohm's law. So the R is equal to 7 and the I1 is equals to I. So we have written 7I, then 31 voltages, then 4 into I1 minus I3. Here I1 minus I3 because the 4 ohm is shared between I1 and I3. As per the direction, the I1 is the positive side and I3 is the negative side. Then we have written for I1 minus I2. Here 4 I1 minus I2 because the 4 ohm, this 4 ohm is shared between I1 and I3 meshes. So we have got one equation. Applying KVL in mesh 1, we will get two more equation applying KVL to other meshes. Then after solving this 1, 2 and 3 equations, we will get our I1, I2 and I3. So this is our mesh analysis. Our second topic is about node analysis. So we will know what is node analysis, how to solve the node analysis. So node analysis provides a general procedure for analyzing circuits using node voltages as the current circuit variables. So we will find the voltages in this node analysis. To solve the questions related with the node analysis, we need to know the following terms. The first one is Kirchhoff's current law, that means KCL, and the second thing is Kirchhoff's voltage law. Previously we knew the Kirchhoff's voltage law. Now we will describe about the Kirchhoff's current law. Here Kirchhoff's current law means the summation of currents in a node is equal to 0. Then the steps of determine node voltages. The first thing is to select the reference node. We will assign the reference node, then we will assign the all of the nodes, then we will apply KCL from the nodes. There is a question about the node analysis. We can see that we have assigned I1, I2, I3 and I0 as the currents, and the nodes are V1, V2 and V3. But there is a voltage source in this circuit. We know that at the time of solving nodes with voltage sources, we need to assume a supernode to the whole loop. The thing is, we need to assume this whole loop as one node. As I said before, that we will get a supernode. The supernode, in the supernode, the KVL is inside. We will do KVL inside the supernode, and we will do KCL outside the supernode. So for the KCL, the 6 volt is as per the roll number. We have replaced the 6 volt as the 1 volt. Then the supernode, the 6 is equal to I2 plus I0, because 6 ampere is going inside and the I2 and I0 is going outside. Then so we can write 6 is equal to, here I2 means the current is going from V1 minus 0, so we will not write 0, divided by 4 as the Ohm's law, plus the 6 ohm is going through V3 to 0. See, solving this equation, we will get this. Applying KVL at 12 and 1 volt separately, because we have got 12 and 1 volt, we will apply KVL inside the voltage, inside the loops. Applying KVL from voltage 12 and 1, we will get these two equations. After solving this equation, we can get V1, V2 and V3. So today's presentation is here about to the end. Hope that we have learned the mesh and node analysis properly. Thank you so much.